Section 9.1.1, we're looking at polynomial models. Nonlinear regression is sometimes called curvilinear regression, and there is a specific number of minimum data points that you need in order to do certain regressions, such as quadratic is 3, cubic is 4, and quartic is 5. Of course, if you were doing something statistical and you were trying to analyze something, you'd want to have a lot more data points than that, but those are just letting you know the minimum that you need. So for the first example, it says the following data, which is based on stats from the Department of Health and Human Services, gives the cumulative number of reported cases of AIDS in the U.S. from 1982 to 2000. We want to find a quadratic, a cubic, and a quartic regression equation and determine which equation best fits the model. So instead of writing all these years in, I decided to let 0 correspond to 1980, which is okay if you do that. Just make sure that you write that down. And so when I did this, I have then 2, 4, 6, 8, 10, and you can see all the rest of the years done. So now I'm going to go ahead and use my calculator in order to look at this and see which one's going to be the best fit. So the first thing you want to do is go to Stat and hit Enter on Edit, because that gives you your list 1 and list 2, and you have other lists in there, of course. If you have anything in there, you can just highlight the list and hit Clear, and then push down and it'll clear it out. Don't hit Delete, because if you hit Delete, you might accidentally delete the list, and then you need to put it back in. So go ahead and pause the video and put your data points in. So you're just putting all the years and then all the, of course, the number of cases in list 2, so the years are in list 1. And then once you have that done, unpause the video, and then we'll go ahead and look at the different regression features that we have in our calculator. So once you have this, we're going to quit out of there, so second mode. We need to do a couple of things first. So we need to go to second 0, which is our catalog. And if you hit the inverse button right here, we're going to scroll down. That makes it scroll faster to the D's. We need to turn our diagnostics on, because this helps us determine which model is going to be a better fit. So once you hit that, hit done, so hit enter, and then it'll say done. So now when we have that, so I'm going to clear that out. I also need to turn my stat plot on. So if I go to second y equals and I hit enter on the first one, I want to hit enter on, and notice that my X list is list 1 and my Y list is list 2. So then I can quit out of there. So I'm going to go ahead and look at my regression. So we hopefully know how to do the linear regression by now. So you just go to stat and then right arrow to calculate. And we've done linear regression before, which is number 4, but we're going to go ahead and look at the quadratic regression. So I'm going to hit enter. So for this, notice it says list 1 and list 2, because those are the lists we're using. You could always change this if you need to, but most often we're in list 1 and list 2. We're going to go ahead and store our regression equation into our y equals, because if you go to your y equals right now, you'll see there's nothing in there. And sometimes these problems can be really long, so it's a lot to have to type that in. So I'm going to go back to stat, calculate, and quadratic regression. So this is a nice feature on these new calculators, because you can easily just store it into your y equals by hitting this button. That's the vars, which stands for variables. And if you look here, if you scroll to the right, you see y vars, which stands for y variables. And we're working with functions right now, so I'm going to hit enter on the first one. And notice this gives you a list of y1, 2, 3, 4. So those are the different, if you hit your y equals button, you'll see y1, y2, y3, y4. So let's go ahead and put ours into y1, and then hit enter to calculate and enter again. So now I have my equation, and you'll notice that you see this r squared right here. So when you were doing linear functions, you had what was called the correlation coefficient. So the correlation coefficient told you how well your data fits your line. And so basically what it was doing was calculating how many points above and below your line you had, and what was the percentage of times that it was hitting it. And so we actually have the same thing, except for similar idea, I should say, and it's called the coefficient of determination, which is this r squared. So you notice for the coefficient of determination, this is again calculating how well your data points are going to be hitting that line. So it's really a nice feature, because the closer to 1 or -1, the better fit the line you have. If it's equal to 1 or -1, that means it would fit all the data points perfectly, which of course doesn't usually happen. So let's go ahead and write this correlation coefficient down in our paper that we have. So that's the quadratic. So we had 0.985, and I'm going to round to 6. So let's go back to our calculator, and in our calculator, if we want to graph this, we already turned on our stat plot. So if we go to zoom and you scroll down to number 9, I don't always usually scroll, I just usually hit 9 and enter. So if I look at 9, it's zoom stat, enter, and notice that the reason we like that button is because it will, of course, pick a correct window to use for the data points that you have. So now you can see that this is our quadratic regression, and the reason that line came up is because I did that store regression, because see, before we didn't have anything in our y equals, but by hitting that store regression equation, it actually put that into my y1 for me. So I'm going to quit out of there. I'm going to go ahead and do the same thing for cubic. So I go to stat, calculate, and we're looking at question our number 6, which is cubic. So now I'm going to store my regression equation again, but this time if I hit vars and scroll to right y vars and function, I'm not going to put it into y1 because that's where my quadratic is. I'm going to go ahead and put it into y2, so that way it'll be in a different y equals and I can look at the equations together on my calculator. So here's my cubic equation, and you can see all the values for A, B, C, and D. And again, we have our coefficient of determination, which is 0.9964. So let's go back to here. So 0.9964. Notice that that is even closer to 1 than our quadratic, so that means that this is going to fit our data even better. So then the next thing that we want to look at, if I go back to my calculator, is our Coretech regression. So stat, calculate, and Coretech is number 7. And let's go ahead and store this into y3. So go to vars, right arrow over to y vars, enter and function. We're going to scroll down to y3, enter, and then calculate. So for this one, because it's going to be a lot larger, notice you see that arrow right here. So that means if you were to actually scroll down and up before doing anything else on your calculator, so don't use the right or left arrows, up or down only, you'll get that bottom value, which is your correlation coefficient, so 0.998, and if we round 6, so let's go ahead to our paper, 0.9986. And as you can see, that one's even closer fitting to my data because it's even closer to 1 than the ones previous to that. So for this, we can actually go ahead and let's write down our Coretech model. So if you go back to your calculator, I'm just going to be writing these values down so you can see that your A value is negative 20.287, so I'm going to do 29, and then we have our B, C, D, E, and E value. So you guys are just writing that down. So my Coretech is y is equal to negative 20.29 x to the power 4 plus 681.94 x cubed minus 4318.57 x squared plus 15,550.81 x minus, I'm going to have to write it below because I'm running out of room, 17877.25. So that is my Coretech model. So this is our best model when looking at the correlation coefficient, which is your r squared. And so if I go back to my calculator, let's actually look at this with all 3 graphs together. So if I hit graph now, you'll see that was our quadratic. Then next it's going to graph the cubic. And then the next one's going to be our Coretech. So this is good, but you can even see right here that our quartic is starting to curve downwards. So in statistics, it's helpful sometimes to actually think about what it is you're talking about. And in this case, we're talking about AIDS cases. And so we know that there's no cure. So that means that in the long run, it might not make sense to actually use a quartic model. So I'm going to go to my window and I'm going to change my window from, I'm going to make it from 0 to 50. And then I'm going to hit graph so I can look at the models again. So there's my first quadratic. Next it's going to be cubic. And then the next one's going to be my quartic. So you can see both the cubic and the quartic, in the long run, their values are going to be decreasing. So that means that in the long run, it might not make sense to use those as your equation because of the fact, like I said, there's no cure, so we know that our values can only be increasing. So I'm going to make a note of that. So the quartic, oops, model fits the given data best for the given years. So for the years that they gave us, Coretech is the best. However, in the long run, since there's no cure for AIDS, we know the quadratic model would be the best fit model. So again, that last part was, however, in the long run, since there's no cure for AIDS, the quadratic model would be the best fit. So you have to be very careful of what it's, asking you sometimes in these questions. So again, according to just the given years, we know the Coretech is the best, but in the long run, if it was asking for that instead, we would say that the quadratic model would be the best fit. So make sure that you know how to, plug these into your calculator, how to get the stat plot, how to make sure to put the equations in your y equals, and how to look at the graph. And again, doing that equation part where you have to look at your coefficient of determination. So we'll go ahead and do more examples in class next.